Welcome to another topic in science, specifically energy. So, today we're going to talk a little bit about what energy is and what we mean by energy in the science world. So, understanding energy allows us to design cars that get better gas mileage, predict what would happen to cars in a collision, and make smart decisions about what foods to eat. So, first, let's talk about what is energy? You might have heard someone say, I am out of energy. Or you might have said, we need to turn the lights off to save energy. You've used the word energy frequently. But what exactly is energy? Like many other words, energy has a particular meaning when used in science. Energy is a measure of the capability to produce change. If there is more energy, there is the ability to make a bigger change than if there is less energy. As we read more about energy, focus on how each example fits this definition. This is our official definition of energy in science. Let's first consider the statement from above, I am out of energy. Like, look at this person. He is just out of energy. In this case, the person talking eats food and stores energy, as most food does. The energy now stored in the person's body can be used to produce many changes. The person could run down the hallway, they could move it across when they move, it creates a change in position, speed, shape, arms out, arms at your side, and even temperature. If you run out of food energy, you cannot go through these changes. The energy from the food allows a person to do work to produce change. So maybe this person just needs to go have a snack. Energy is not matter. It isn't stuff. You can't reach out and touch energy. It is a measure of the capability to produce change. One way of thinking about energy is like money. Like energy, money can be stored or transferred. At first, the value of the money is stored in the paper dollars that you can hold. You can transfer money when you buy something. The value is then stored in the object that you bought. So even though the money is gone, you're storing the value of that money in the object. If you then trade it for another object or sell it again, the money again would be transferred and stored in a new object or in the paper money you get from selling that object. Another commonly used model for energy is that of a special fluid. You can think of energy being stored in cups or containers and then being transferred by pouring between the containers. Thinking of energy like money or fluid may help you remember that energy is a measure of change, not actual stuff that you can pick up. Energy can be stored in different ways. As was mentioned above, energy can be stored or it can be transferred. People often think that there are many types of energy, but that is not so. There is only one kind of energy. However, there are many ways that energy can be stored. Energy can be stored kinetically, which is known as E small k, because of the motion. So kinetic energy is motion of an object. Positionally, which stands for EPG, because of the position of the object against gravity. So EPG stands for energy potential due to gravity. Basically, this means the object could fall somewhere. So if it's in a tree or on the top of a slide, sitting on the floor, we would say it does not have EPG. Another one is positionally for EPE, and this is because the object is elastic, stretchy, or springy. So when you pull on a rubber band, it would then have EPE, energy due to the position of it being elastic. Thermally, ET, because the motion of the particles that creates heat. So movement of particles, like think about rubbing your hands together, that creates thermal energy, ET. Chemically, EC, this is the arrangement of the particles that make up a substance. This would be things like food and fuels. So the apple that you eat or the gasoline in your car is EC. Electrically, EE, because of the position and movement of electrons. So anything that has a plug or a switch or batteries, this would be any type of EE, electric energy. And then nuclearly, En, this is because of the arrangement of protons and neutrons in an atom, or specifically in the nucleus of an atom, which is why it's protons and neutrons. The protons and neutrons are in the nucleus inside atom. All the atoms are those tiny things that make up everything. So this would be things like a nuclear bomb or a nuclear power plant. These are the different ways that you store energy. So maybe you can think now, maybe some other examples of these different ways to store energy, and we'll talk more about that later. Energy can also be transferred between objects. This is done in three ways. Radiation. This is giving off light that we can see or other types of magnetic waves like radio waves or microwaves or even things like X-rays. Those waves given off are transferring of energy. You can also transfer energy by heating something. This is when two objects are in contact and they have different temperatures. So like when there's a fire, that can produce a transfer of energy through the cold air to your cold hands. Or if I put a metal object in that fire, then that can transfer heat to that metal object, and now that metal object will have a higher temperature. That's transfer of energy. And then also by actually doing work, which means that you are using a force, a push or a pull, over some distance, like walking up a set of stairs. You are using a force to move your body from the bottom to the top, and you could also think about like gravity could be trying to pull you down, so you have to overcome that force. So movement from somewhere to somewhere else usually takes a force. That's some amount of work. The next thing you want to talk about is that energy can be conserved. To be conserved means to have the same amount of something at any 2 points in time, like the beginning and the end. Some people say if something is conserved, it cannot be created or destroyed, just stored or transferred. This is certainly true of energy. Energy is a conserved quantity. This means that if no energy is added or taken from an object, it will have the same amount of energy at any 2 points in time. The energy may be stored in different ways, but the total amount will not have changed. So this person at the top has maybe more potential energy, and then once this person starts going down the slide, they have more kinetic energy, but the total amount of energy between them could be the same. It's just transferred or stored in different ways. And the last topic here we want to talk about is measuring energy. Remember that our definition of energy is a measure of the capability to produce change. In other words, the measurement of the ability to make something different. Energy is measured in joules. J is the symbol for that. A car moving down the highway speeds may store 1 million joules of energy, EK, because it's moving really, really fast. While a cup sitting on a counter may store 2 joules of energy, position, gravity, because it could fall off the table. But because it's so much littler, it doesn't have as many joules as a car that is speeding down the highway. This makes sense because the car is capable of producing much more change than the cup. Imagine getting hit by the car versus the cup. If you got hit by the car, the change you would feel would be a lot more if you got hit by the cup. So thanks for listening on our introduction to energy. Now what I'd like you to do is do a respond to this reading. You're going to do something called a critter diagram. So in the space below on this page, you're going to create something known as a critter diagram. It's called that because when you're done with it, it kind of looks like a spider or a critter with legs and then different like feet or fingers. So you're going to put the word energy in the middle, and then you're going to put 4 different subtopics, or at least 3, coming off of energy, and then you're going to put details about that subtopic on the fingers or the toes. So if this is the body, these are the legs, these would be the toes. So energy in the middle, at least 3 legs or subtopics of energy from the reading, and then details about that subtopic go off of the leg or the arm. So that's what I would like you to do next. Basically, you're summarizing the reading in this kind of fancy format. If that doesn't make sense, please ask, and then when you're done, show Miss K, and then you'll submit it as an assignment. Thanks for listening about energy. Bye.